Welcome to Penguin Engineering. In this video, we're going to show you how to check for faults on your ATI calorifier, and this can apply to many compatible calorifiers. Here are the most common spares that you're likely to need. Firstly, we have replacement anodes. ATI stainless steel calorifiers are anode free, but you will need them for our blue enameled units and some other makes. Next, we have some 230 volt elements that range between 500 to 1200 watts. We also carry a 110 volt version. This is a thermostat which works with any of these elements. You need a fresh gasket whenever the element is withdrawn or replaced, and we also supply this handy tool. All of these are clearly displayed on the Calorifier Spares section of our website. Moving across to the calorifier. This is an unplugged test unit on which we're going to change the element. For this, you'll need the removal tool we just mentioned, a multimeter, some screwdrivers and some blue Loctite 243 to seal the thread. Before working on anything, however, it's essential that you fully isolate the power supply and fully disconnect the unit. You must only proceed from here if you're competent to do any electrical work. Remember, this is high voltage equipment. Having disconnected the calorifier from the power and drained the system down, you first need to grab a small crosshead screwdriver and remove the plastic cap. Put the screws somewhere safe before you drop them in the bilge. Now the cover is off, you can clearly see the wiring. The live and neutral wires are connected to the thermostat, and the ground wire is attached to the body of the calorifier. At this point, it may be worth taking a photo of the connections to remove any doubt when you put it back together. The terminals are marked on the top of the thermostat. There is an A for the brown live, B for the blue neutral, and here is where the ground wire is attached to the body of the unit. Now we're going to remove the wiring. You don't need to take the screws all the way out, just undo them enough to allow the ends to slip away. Next, we'll remove the thermostat. This has bayonet fittings into the top of the element, and don't be surprised if it's tight. Take a flathead screwdriver and prise it off. Now the thermostat is removed, you can see the bayonet connections that you've just released. So here's the top of the element itself, disconnected from the power supply, and before we remove it, we're going to test it using a simple multimeter. We've set the meter onto ohms to check the resistance in the element. To test the multimeter, we'll touch the ends of the probes together. It's showing a dead short, which means it's working. Now we're going to test the element, which we've made sure has been disconnected from the power supply. We'll place the probes on the terminals, and we can see here a reading of around 40 ohms. This shows that the element is working fine. If the reading shows a dead short, then the element is burnt out and will need to be replaced. If the reading shows an open circuit, this also tells you that the element needs to be replaced. Here you have a simple chart telling you the correct resistance in ohms for all the elements that we supply. We're assuming this element is defective, so we're going to remove it using the tool. The element in this video has already been loosened off, but the threads will have been sealed with Loctite at the factory, so expect plenty of resistance when taking it out for the first time. This is one of our blue enamel calorifiers, which comes with an anode. If your anode is substantially degraded, it will need to be replaced. To fit the new element, first screw in and tighten up the replacement anode if it needs one. Fit a new gasket and make sure the thread is clean. Get some Loctite, put plenty on the threads, screw it in by hand and make sure it's tight. Here's the thermostat again, and before we put it back together, we're going to run a couple of tests. On the top here is a simple dial with markings from 1 to 5, with 1 being the lowest and 5 being the hottest, over a range of 13 to 65 degrees. Turn the dial all the way up to 5 and make sure this little reset button on top is pressed down. Take your multimeter and set it again to ohms. Place one probe on the lug beneath the thermostat and the other onto the corresponding connection on top. You can see on the multimeter that the circuit is complete. telling you that electricity is flowing. Do the same again on the other corresponding terminals, and again we can see the circuit is complete. Now turn the dial all the way down to 1 and you should hear a click, which is telling you that the temperature has been achieved. Put the multimeter across the neutral terminal and you can see here that it's still showing a complete circuit. Go across to the live terminals and now the circuit is open. This is telling us that the thermostat is working correctly by stopping the flow of electricity when it's reached temperature. If it's not working correctly like this, or if you have any doubts, it needs to be replaced. Don't be tempted to take the thermostat apart, as the bimetal strip inside is likely to be damaged in the process and you won't be able to recalibrate it. Now we know the thermostat is working fine, we're going to reinstall it. Before doing this, make sure the reset button is still pressed home and set the dial on the thermostat to the position you're happy with, or otherwise set it to the middle position, number 3. Line up the probe with the probe holder, align the bayonet connections and press it carefully but firmly back into place. You can now refer back to your photo to check the wiring positions. Screw the terminals back down and press the earth back into place on the surrounding metal as before. Then you can replace the cap, making sure you don't over-tighten the screws. Another component you may need to check from time to time is the pressure relief valve. Current ATI models have 8-bar valves indicated by a blue handle. Older models have a 6-bar valve with a black handle. If you notice any weeping from the relief valve, this may be down to some debris on the inside. To clear it, make sure the water isn't hot and then open the valve to drain some water out. If it doesn't work, it may be that your expansion tank or your accumulator has lost pressure. It should be around 1.5 bar. If there is little or no pressure, then the bladder inside or maybe the complete accumulator need to be replaced. I hope you found that video helpful. If you need any help with any of our calorifiers, accessories, or indeed any other of the products we supply, please get in touch with us at Penguin Engineering.